Article 230.72 addresses the disconnection of grounded conductors. However, there are exceptions to the general rule that all service disconnecting means must be grouped together. Exception No. 1 covers conductors and busways. Exception No. 2 pertains to branch circuits supplied from a secondary unit transformer and protected by a device within or adjacent to the unit transformer enclosure. Exception No. 3 addresses fuses installed in panel boards within sight of the disconnecting means to which panel boards are connected. Exception No. 4 allows separate disconnects located at each load center with the lowest rated disconnecting means rated at not less than 60 amps. The key to understanding if the described project complies lies in Exception No. 4. This exception explicitly allows for separate disconnects at each load center, provided that the lowest rated disconnect is rated at not less than 60 amps. Therefore, the primary argument should be built around demonstrating that the project meets the requirements of Exception No. 4. Explain that the disconnecting means are located at each service, which are effectively the load centers for each individual service. Emphasize that each service is independent and protected by its own disconnecting means. This ensures compliance with the fundamental requirement of Article 230.72, which is the disconnection of grounded conductors. The NEC does not require the use of shunt trap devices to achieve the grouping of disconnecting means in situations where Exception No. 4 applies. Insisting on their use in this case, when the code allows for separate disconnects, is not supported by the NEC. Verify that the disconnecting means for each service is appropriately rated for the full load current of that service. This is a fundamental requirement for any service disconnect installation. Provide clear and permanent labeling and identification for each disconnecting means and its associated service. This is crucial for safety and ease of maintenance. Ensure that each disconnecting means is readily accessible and not obstructed. This is another key safety requirement. Accessibility ensures that the disconnect can be easily reached in case of an emergency. Consider the specific requirements for the short circuit current rating of the service equipment. All components, including the disconnecting means, must have a short circuit current rating sufficient to withstand the available fault current at their point of installation. The available fault current should be determined through a proper engineering study. Consider the type of overcurrent protection being used. Fuses and circuit breakers have different characteristics and interrupting ratings. Selected overcurrent protection must be appropriate for the application and coordinated with the other components in the system. Ensure that the grounding and bonding system is properly installed and maintained. This is critical for electrical safety and to minimize the risk of electrical shock. The grounding system must comply with Article 250 of the NEC. Consider the coordination of overcurrent protective devices. Selective coordination ensures that only the overcurrent device closest to the fault opens, minimizing the extent of the outage. Selective coordination is often required in critical applications. Consider the voltage drop in the system. Excessive voltage drop can cause equipment malfunction and reduced performance. Conductors should be sized appropriately to minimize voltage drop. Consider the ambient temperature and derating factors for conductors. Conductors must be derated for high ambient temperatures or when installed in close proximity to other conductors. The NEC provides tables for ampacity derating. Consider the requirements for working space around electrical equipment. Sufficient working space is required to allow for safe operation and maintenance of electrical equipment. The dimensions of the working space are specified in Article 110.26 of the NEC. Consider the requirements for arc flash hazard analysis. An arc flash hazard analysis is required to determine the potential arc flash hazards in the electrical system. The results of the analysis are used to select appropriate personal protective equipment for workers. Review the applicable local amendments to the NEC. Local jurisdictions may have adopted amendments to the NEC that are more stringent than the national requirements. Be aware of any such amendments that apply to the project. Consult with a qualified electrical engineer. An electrical engineer can provide valuable assistance in designing and reviewing the electrical system to ensure compliance with the NEC and other applicable standards. Maintain accurate and up-to-date documentation of the electrical system. This documentation should include drawings, specifications, and calculations. Accurate documentation is essential for maintenance and future modifications. Use only listed and labeled equipment. Listed and labeled equipment has been tested and certified by a recognized testing laboratory to meet applicable safety standards. Ensure that all electrical work is performed by qualified and licensed electricians. Electrical work should only be performed by individuals who have the necessary training and experience. Obtain all necessary permits and inspections. Electrical work typically requires permits and inspections from the local building department. These permits and inspections help to ensure that the work is performed safely and in accordance with the NEC. Follow the manufacturer's instructions for installation and maintenance of electrical equipment. The manufacturer's instructions provide important information about the proper installation and maintenance of the equipment. Provide training to personnel who will be operating and maintaining the electrical system. Proper training is essential for the safe operation and maintenance of the equipment. Conduct regular inspections and maintenance of the electrical system. Regular inspections and maintenance can help to identify and correct potential problems before they cause a failure or hazard. Keep the electrical equipment clean and free from dust and debris. Dust and debris can accumulate on electrical equipment and cause overheating or other problems. Properly support and secure all electrical wiring and equipment. Wiring and equipment should be properly supported and secured to prevent damage or accidental contact. Protect electrical wiring and equipment from physical damage. Wiring and equipment should be protected from physical damage by conduit, enclosures, or other means. Use appropriate wiring methods for the application. The NEC specifies different wiring methods for different applications. Select the appropriate wiring method for the specific application. Properly terminate all electrical connections. Electrical connections should be properly terminated to ensure a reliable and safe connection. Use appropriate tools and techniques for making electrical connections. Use the correct type of connectors and terminals for the application. Avoid over-tightening or under-tightening electrical connections. Properly torque all electrical connections according to the manufacturer's instructions. Use a calibrated torque wrench to ensure that electrical connections are properly torqued. Inspect electrical connections regularly for signs of corrosion or looseness. Repair or replace any damaged or corroded electrical connections. Protect electrical wiring and equipment from moisture. Moisture can cause corrosion and electrical shorts. Use waterproof or weatherproof enclosures and fittings in wet or damp locations. Provide adequate ventilation for electrical equipment. Electrical equipment generates heat, which can cause overheating if not properly ventilated. Ensure that electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protective device and preventing an electrical shock. Use appropriate grounding conductors and connections. Test the grounding system regularly to ensure that it is functioning properly. Provide surge protection for sensitive electronic equipment. Surge protection can help to protect sensitive electronic equipment from damage caused by voltage surges. Use surge protective devices that are listed and labeled for the application. Inspect surge protective devices regularly to ensure that they are functioning properly. Consider the use of uninterruptible power supplies for critical equipment. Uninterruptible power supplies can provide backup power in the event of a power outage. Select uninterruptible power supplies that are sized appropriately for the load. Inspect uninterruptible power supplies regularly to ensure that they are functioning properly. Implement an arc flash safety program. An arc flash safety program should include training, hazard analysis, and the use of personal protective equipment. Provide arc flash training to all personnel who may be exposed to arc flash hazards. Conduct an arc flash hazard analysis to determine the potential arc flash hazards in the electrical system. Select appropriate personal protective equipment for workers who may be exposed to arc flash hazards. Establish lockout-tagout procedures for de-energizing electrical equipment. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Provide lockout-tagout training to all personnel who may be performing maintenance or repair on electrical equipment. Use appropriate lockout-tagout devices. Inspect lockout-tagout devices regularly to ensure that they are functioning properly. Implement a confined space entry program. A confined space entry program is used to protect workers who enter confined spaces. Provide confined space entry training to all personnel who may be entering confined spaces. Conduct a hazard assessment before entering a confined space. Use appropriate personal protective equipment when entering a confined space. Monitor the atmosphere in the confined space for hazardous gases or vapors. Provide ventilation to the confined space if necessary. Establish rescue procedures for confined space emergencies. Implement an electrical safety program. An electrical safety program should include all of the elements discussed above. Review and update the electrical safety program regularly. In summary, the key to convincing the inspector lies in a thorough understanding and clear articulation of Exception No. 4 of NEC Article 230.72, combined with diligent adherence to all other applicable code requirements and safety best practices. Always prioritize safety and code compliance in all electrical installations.